modeling turbine blades, modeling the flow around a jet fighter. Some of these codes are indeed finite element based, modeling the fluid flow, doing the CFD. So it does. I use it basically to use. I've used it for CFD. My approach is using. In many cases, is using finite element approach. Studying race cars. This is a BMW graphic modeling the flow around one of their race cars. It's increasingly applied in the medical field for modeling bone, skeletal features, understanding bone fractures and all kinds of aspects of the human body. This is a analysis of a knee joint and the various components in the joint. Now, I already mentioned that I applied the finite element method to modeling the Earth's mantle as part of my PhD thesis almost 40 years ago. The objective was to demonstrate that the mantle is unstable to a runaway instability that I was persuaded was responsible for the large-scale tectonic aspects of Noah's flood. And so that effort was, in my opinion, very successful. Got blessed incredibly. Just to help you understand a little bit about the Earth. Earth can be basically divided into two parts, the core and the mantle. Core is mostly liquid iron, and the mantle is almost everywhere solid, and made of polycrystalline silicate minerals, polycrystalline silicate. And so it's because the surface is so much colder than the interior of the Earth, there's a top boundary layer known as the lithosphere, which is cold enough to be mechanically rigid, and typically broken into about a dozen large plates that more or less slide with very little internal deformation over a much weaker layer called the asthenosphere. On average, the asthenosphere is about 1,000 times weaker than the lithosphere. So that enables these plates to move with very little traction over the underlying rock. An aspect that I've focused on is the fact that rapid plate motion can occur because mantle rock weakens under stress. Laboratory experiments show that that's the case. And so I've shown that almost certainly during the flood, there was a runaway sinking of the surface layer, this lithosphere, into the mantle instead of a few centimeters per year, as is currently occurring, at speeds on the order of meters per second, which is about 1 billion times faster. And I believe that was the means by which God judged the Earth, caused the entire surface of the Earth to be replaced, essentially, in just a few months' time. So, just a little bit on constitutive model. This is from a publication from 1983. Already many experiments have been done on how silicate minerals deform under stress at various temperatures. And so this is a a plot of temperature. Tm is the melting temperature. This is 80% of the melting temperature, and also as a function of stress. Both normalized shear stress with respect to the shear modulus are absolute stress. And basically, if you follow this line at 80% of the melting temperature, the strain rate changes by about 10 orders of magnitude from up here to down here, with a relatively modest change in stress. So it shows that these stress numbers are the sort of stresses that you would expect inside a planet the size of the Earth, as gravity acts on density anomalies in the mantle. So one thing I did was to represent this stress strain curve, stress strain rate curve, in a few simple mathematical equations, put it into a finite element code, and this is and what I find is that for this simple initial condition, a cold upper boundary, a hot lower boundary, you get a seeking blob, and that can run away. This is actually in days here. You have the blob able to sink through about 2,800 kilometers of mantle in just a week's time because of this runaway instability. So the physics works. The physics of this, but it's so I'm able in just this simple 2D calculation where the height of the box is equal to the depth of the mantle. I'm able to get high resolution and model this accurately. It's much more of a challenge to get that kind of resolution in 3D. But these 2D calculations, for anybody that understands the physics, is powerfully persuasive about the mechanism working, this runaway mechanism. Okay, now for my thesis, however, I developed a 3D finite element model for the mantle. And I won't go into a lot of the details of the type of elements, but I used an almost uniform spherical mesh. I'll show in a second. To solve the equations, I used a brand new method just discovered in that day called multigrid to solve the momentum equation for velocity with extreme efficiency. So this allowed this type of calculation to be done for the very first time in 3D. It turned out later that this mesh that I used